Today we have a few short things to do. We want to deal with the subtraction of fractions. We'll also be talking about mixed numbers and improper fractions. So these are fairly straightforward ideas, but let me remind you of what we did last time. So just as a reminder of what we did last time. So remember last time when we met, we were doing chapter 3.1 essentially, but there were really important ideas. We learned something about two meanings of fractions. That was one thing that we learned about. The two meanings or two interpretations of fractions. That was one thing. And then we also learned about how to add two fractions. So addition of fractions. Right? And they could be with the same denominator or with a different denominator, addition of fractions. That's another thing that we learned. And while we were talking about addition of fractions, we also learned about equivalent fractions, sort of revised equivalent fractions. So any questions about last time? Koi cheez confused kar rahi hai about last time? All good. Good. So today, last time was a bit heavy on concepts. This time, today is going to be fairly easy and fairly straightforward. We don't have any new concepts coming in. So let's talk about section chapter 3.2, which is subtraction of fractions. So now once we know addition of fractions, and you have the concept of subtraction from earlier grades, then subtraction of fractions is easy. Subtraction, because it's known, there's no new concept here. Okay? So all the heavy conceptual weightlifting was done in the previous lecture. We know what subtraction means. We know various interpretations of subtraction. So that same things hold now. We also know what fractions are and how to subtract fractions. So if I were to ask you, let me just ask you, if you have 7/8 minus 2/8, right? So what would be the answer? 5/8, because we are thinking of it as exactly, we have eighths. So we have 7/8, like 7 apples, and we have 2 apples. So if you have 7 apples and you eat 2 apples, you're left with 5 apples. So this is our interpretation, very straightforward interpretation. This is a part of a whole interpretation. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 equal pieces. Remember, equal means whatever you want it to mean. I had 7 pieces out of the 8. So this is what I actually had. I had 7 pieces out of the 8. And I gave away 2 pieces. So these 2 pieces were given away. So I'm left with 1, 2, 3, 4, 5 pieces. 7 pieces minus 2 pieces is 5 pieces. That's the only interpretation. So that's easy, right? Okay. And you can do things like, maybe if you have a whole minus, let's say, 3/10. Now remember, if I have a whole and I want to subtract away 3/10, one thing that I can do is,
that means that the whole is like 10 over 10.
Exactly, that's exactly what we're going to do. So we're going to think of a whole as 10 equal pieces. 1, 2, 3, 4, 5, 6. I'm going to run out of space. 7, 8, 9, 10. So I have 10 equal pieces, and I'm going to take away 3 of them. So I'm going to be left with 1, 2, 3, 4, 5, 6, 7, because this is just 10 over 10, which is a whole, minus 3 over 10. That's just going to be 7 over 10. That's again a similar thing. And now if I want to do maybe a half minus, now I want to do it with different denominators. So if I have maybe let's do something a bit more interesting. Let's do maybe 7/8 minus a half. So I want to do this subtraction. So what I'm going to do is I have I have 8 pieces. 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 equal pieces. And now I want to subtract half of them. So now that's a problem because again they're not on the same denominator, but I know how to do it. So remember, if I want a half of something, there are 8 pieces. What's a half of 8 pieces? 4 pieces. So that's going to be 4 pieces. 1, 2, 3, 4. So this is a half. Okay. So now what I have is I have 7 pieces out of these 8 pieces. These are 7 pieces out of the 8 pieces, and now I'm going to give away 4 out of those 8 pieces. So I'm going to be left with 3 pieces, right? So the way that happened was because I took my half and broke it up. So I actually combined my 4 small pieces to make a big half. That's what I did. So I had 7 over 8 minus 4 over 8, which was equal to 3 over 8. And a different way of, maybe I should have done it in a slightly different way. Maybe it's slightly confusing. Let me rework this out in a slightly different way. I let this stay, and I'm going to do the same question in a slightly different way, and you'll see the ideas were similar but not exactly. So let's do 7 over 8 minus a half, but now I have a half. That's what you were starting with. So I apologize, I think slightly different. So here's a half. This is a half, right? That doesn't look like a half. It doesn't look like a half. It looks a bit skewed to the right. Okay, so this may look a bit more like a half. Okay, so now I have a half. And now what I want to do is, so I'm going to eat a half, but I have 7/8 of the whole thing. So I don't know how to go from a half to 7/8. So what do? I break up each piece into 4 equal pieces, right? 1, 2, 3, 4, and 1, 2, 3, 4. And now I know that I'm starting with 7/8, and I'm going to eat a half. So I'm going to be left with 3/8, and a half is the same as 4/8. Okay, it was slightly different. What I had was I started with 8 small pieces, and I combined 4 small pieces to get 1 half, and I combined 4 small pieces to get a half. Okay, so slightly different ways of thinking about something which is very similar to each other. Okay, clear? Any questions? Sorry for the slight confusion. All good? Okay, so this is, I guess, all that I have to say about subtraction of fractions, because there isn't much to subtraction of fractions. Any questions here? No? Okay, good. So now I want to talk a bit about, this is really annoying terminology. So now we're going to talk about mixed numbers and improper fractions. It's almost like a waste of time to worry about these terminologies. It's just fractions and common sense, but we have to go through it because everybody uses this terminology, so we also have to learn this terminology. So what about mixed numbers? So the deep idea of mixed numbers is, I'm being sarcastic, so here's a hole. So let's say you have 2 holes. Okay, they don't look identical holes, they should be identical holes. So there are 2 holes, okay, and now so these are 2 whole apples. Okay, and maybe somebody comes around and gives you 2/3 of an apple more. So here's a hole, but he doesn't give you a whole apple. He's going to break it up into thirds, and he gives you this amount of. So your apple empire consists of the yellow that you have. So now you have 2 holes, and you have plus 2/3 of an apple. Okay, so now how do we write it? Well, the way we write it is, again, this is what it actually means. It just means this is just equal to 2 holes, 2/3. So I have done nothing, I have done no calculation. This is a way of rewriting. So this equality is not a calculation. It's really a rewrite of this number. 2 plus 2/3 is just 2 over 3. Okay? This is clear? It's just a rewrite. There's no calculation. Now there's one mistake that a lot of people make and they forget. Please remember this. It's a trivial thing but very annoying, which is that when you are writing this mixed number, please make sure that this fraction line is above the line that you're writing on. Because if you don't do it, it's possible for it, now this becomes very confusing. If you write it this way, this can be interpreted as that you just forgot to extend this line a bit more, and now is it 22 over 3 or 2 wholes 2 over 3? Okay, is this clear? So the line has to go slightly above it, and if you note your book, in the book also, just line pe the book is writing, the fraction goes slightly above that line. Okay, so please make sure when you're writing that the line goes slightly above the writing line. Okay, not 22 over 3, because especially in an exam, I'll see this and I'll get very confused and I may decide this is 22 over 3 and not 2 whole 2 over 3. Okay. So just a trivial little thing, but important to make sure that just when we write in place value, we have to be very careful about the columns. The columns have to be aligned, and it's a very important thing. This is true in division, multiplication, addition, and subtraction. Place value is based on place. The value is based on place. So if you mess around with the place, God help you. Okay. Similarly, यहाँ पे it is very important to make sure the line goes above for clarity of understanding. ठीक है? Okay. So this is all. This is called a mixed fraction. So let's do a problem like you have 3 wholes, and now you want to subtract maybe 2/5 from it. Okay. Now how do we do this messy looking problem? Well, you can take the 3 wholes and break it up into 2 plus 1, right? So this is just equal to 2 plus 1 minus 2/5. And now you certainly know, you already know how to take 1 whole and subtract 2/5 from it. That's going to be 5 over 5 minus 2 over 5, which is going to be 3 over 5. So then you'll have 2 plus 3 over 5, which is just equal to 2, 3 over 5 as a mixed number. Okay, this is called a mixed number. But this is how you would think of it. So you're taking 3, breaking it up into 2 plus 1, and then you know how to subtract from 1 2/5. Okay, all good? Any questions about this? Okay. Now we are also going to deal with improper fractions. Again, there's nothing improper about the improper fractions. They're as proper as any other fraction in the world, but it's just a name that comes out of some historical artifact that I don't know why people call them improper fractions, but they are very much proper fractions. Like, they're as good a fraction as any other fraction in the world. So now let's look at this one, and so let's look at this one. We had 2 wholes. So now I want to talk about, this is now improper fractions. I do not like this name at all. It's very annoying. Improper fractions. Okay, so we have 2 wholes. Here are 2 wholes. And here are 2 wholes. And now what I want is, and I had just 2/3 out of it. Remember, I had just 2/3. So this is what we had, and so this was our story. This is what we had, right? So I just had 2 wholes and 2/3, because the mean person only gave me 2/3 of an apple, never gave me the whole apple, right? 2 wholes and 2/3. So now what I can do is I can interpret it in a slightly, so this was 2 wholes and 2/3. We all agree with that. But now what I can do is I can imagine chopping up my apple into each of these apples into 3 equal pieces. Remember, I have this part too. I have all of these parts. So I can chop up this apple into 3 equal pieces. And now how many thirds do I have? 3 plus 3, 6 plus 2, 8. 8 thirds, right? So this I can rewrite as 8 over 3. So what I mean by an improper fraction is when the numerator is larger than the denominator. So this is a very good fraction, but just that the numerator is greater than the denominator. Now, and the way you do it is because you are dealing with thirds, and you have, so each whole will have 3 thirds, right? So if I have 2 wholes, I'll have 2 3/3, which will be 6/3. So you multiply 2 by 3 to get 6/3, okay? So in general, if I have a more complex thing which I don't want to draw, 7, 5 over 6. So now I want to write it as an improper fraction. This is a mixed number, I want to write it as an improper fraction. So now I have 6. So each whole will have 6 sixths, and I have 7 wholes. That means I have 42, 7, 6, yeah, 7, whatever. I have 7, 42 6, because each whole has 6 sixths. So 7 times 6, 7 sixes are 42, and then plus these 5 sixths will make, yeah, so this will make 7 times 6 plus 5 over 6, which is going to be equal to 47 sixths. Okay, this is the way you think about them. Now, just as an aside, do you have a question about this? You may want to muse about what we said last time, and then maybe have a question about the fraction interpretation. The interpretation, the fractions, which seems good now and which seems with improper fractions. Is there an interpretation that seems a bit weird? But remember, we have 2 interpretations of fractions. The parts of a whole.
Yeah, and division.
Yeah. So the division interpretation is very simple. You have 47 apples, you have to give them to 6 people. How do you do that? Each one gets 47 over 6, and you can see how you would do that, right? Because there are, well, I'm not going to draw the 47 apples, but here's one apple. You can see I want to do it equally. 1, 2, 3, 4, 5, 6. And I hope you won't ask me to draw the 47 apples. Even if you do, I'm not going to draw them. 1, 2, 3, 4, 5, 6. So these are 47 apples. And I have to distribute them among 6 children. What do? Well, I take one apple and break it up into 6 pieces and give you 1 piece. And the next, and the next, and the next. So 47 divided by 6 is, yeah, that's what the interpretation is. Now, we had also an interpretation of parts of a whole. So now what's the whole that we are going to consider for 47 over 6 is the question. What's a whole?
6 would be the whole.
What's a whole? Is this the whole? So if this is a whole, I take a whole, break it up into 6 equal pieces. That's good. And now I have to take 47 of these. Well, I only have 6 pieces. I can't give them, right? So now what you have to do is you have to sort of, so that you can do it in multiple ways. One way is imagine that you have lots of apples, okay? So this is what you're going to interpret. So you have infinitely many of these, as many as you want to, okay? So you have a whole orchard of apples, okay? So now just do and now you can 1, 2, 3, 4, 5, 6, and then you continue counting 7, 8, 9, 10, 11, 12, 13, 14. Do you understand? This is a slightly different way of thinking about it. It's not exactly the same thing. There is another way that you can think about it, which is as a part of a set, but that's again, so this is what you would do. So you take a whole, which is an apple, break it up into 6 pieces, 1, 2, 3, 4, 5. This is not 6, this is 6 pieces. And then you imagine there are more apples. And as many, they don't have to be 47 apples anymore. So this is as many apples as you need to. Okay? So 1, 2, 3, 4, pathetic. 5, 1, 2, 3, 4, 5, 6. And more. 1, 2, 3. I can never get it right. Okay. 4, 5, 6. And dot. And now what I'm going to do is I'm going to take every apple and break it up into 6 equal pieces and start counting these pieces. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, dot, dot, dot. Eventually, I will get to a point where I have these 1, 2, 3, 4. Oh, I have to draw it bigger. So eventually, and we can calculate when eventually it is 1, 2, 3, 4, 5, 6. And then you're going to get to 35 pieces. Then, you'll get to 42 pieces. Then this will be the 43rd piece, the 44th piece, the 45th piece, the 46th piece, and the 47th piece. Okay? And you would have gone through, right, by this time, ये जो maybe I should have इसको मैं dot 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 यहाँ पे करता हूँ मैं, this would be better. So dot dot dot, and this would be 3, 4, 5. This would be 35, 36, 36, 37. The class is smarter than me. 39, 40, 41. Oh. 1, 2. Oh, yeah. Sorry, I am completely. Okay, good. So at least the class is alive and I am doing silly things. So let's try again. 1, 2, 3, 4, 5, 6. And I'll start with 30, 37, 38. Because 36 will get completed over here. We started from 1 and not 0. Okay, so 36, 37. Oh, okay. Okay, I've lost my counting also. So 39. Not only do I not know how to multiply, I've lost my ability to count. Okay, 42. Okay. So what we're going to have is 42 pieces take, and this will be, the total will be 6 holes here, 7 holes here. 7 holes here. We'll have 7 holes because each piece contains 6. So 7 6s are 42. So we'll have 42 pieces here. Then we'll have 43, 44, 45, 46, 47. So this is a different interpretation of what 47 over 6 means. So it's kind of a messy interpretation. It's not as nice as part of a whole interpretation anymore. When you extend it to improper fractions, parts of a whole interpretation it's there, you can use it, but it's not as nice as when we did not have improper fractions. But the division interpretation still is very clean and neat and still holds true. So you can see that the number of pieces that you get, 47 over 6, is equal to, so this is exactly the same as this because you're just taking 47 of these small pieces. So it's the same amount of apple that you're getting. Okay? So I guess this wraps up all that I had to say about mixed numbers and improper fractions. Next time we're going to do something which is a bit more, again, interesting, which is going to dealing with how do you deal with fractions when you are dealing with sets. So if you say 2/5 of a class has done well, what does it mean? So that's what we're going to talk about next time. Okay, thanks.